We started studying horizontal cantilevers when we studied Pier Luigi Nervi. We looked at his Florence Stadium and his Flaminio Stadium. Torroja's Zarzuela Hippodrome, again, another horizontal cantilever. So here again, we can illustrate the many possible solutions to the challenge of creating a concrete horizontal cantilever covering a stadium. Looking at these two designs, we see that they're a little bit different. The same idea of a horizontal cantilever providing shade to the spectators, but a very different approach. These two designers, Torroja and Nervi, had two different approaches to design. Torroja was an academic and a designer. Nervi was a builder and a designer. And they approached their designs with this mentality. When David Billington lectured on Torroja versus Nervi, he explained the differences looking at the three perspectives: scientific, social, and symbolic. Professor Billington would say that Torroja preferred the complex, whereas Nervi would prefer the simple in the context of forms, analysis, and construction. And his thesis was that since Torroja was an academic, he preferred the complex, whereas Nervi was the builder, so he preferred the simple. I've thought about this. I'm not so sure that this is actually coming out in the designs. When I look at Torroja's designs and Nervi's designs, I don't see this very clear distinction between complex and simple. This was David Billington's thesis. You decide for yourself how you think about it. Study Torroja and study Nervi and think about it. Is that true or not? From the social point of view, we have Torroja, who has a lab inside of his university that he uses this lab to create scale models, and these scale models inform his design. Whereas Nervi has decades of field experience as a builder, and that informs his design. From the symbolic perspective, the appearance, we see Nervi is using ribbed forms, the art historical tradition of Italy, and Torroja and the Spanish designers in general are using ribless forms and smooth surfaces. The Algeciras Market Hall was designed by Eduardo Torroja in 1933. It has 156-foot diameter, or 47.6 meters, and it's 3.5 inches thick, almost 90 millimeters thick, which gradually increases to 18 inches, or 457 millimeters, at the supports. In between the 8 supports are arches that stiffen the vaults, and these arches are in the form of an eyelid. There are wires that stabilize this arch from buckling, and 16 steel rods connecting the 8 supports that are pre-stressed. The horizontal reaction imposed by the dome is carried out by this tension ring, which are those pre-stressed rods mentioned previously. What you don't see in the dome is how he laid out the steel reinforcement inside of the concrete. He laid out that reinforcement in the same pattern as the stress trajectories. This is similar to Nervi's Gatti wool factory, where the pattern of ribs in this slab follows the pattern of stress trajectories. In Nervi's design of the little sports palace, we see the ribbed pattern. In Torroja's design, it's smooth on the outside and on the inside. In addition, Nervi uses many supports through those inclined buttresses, whereas Torroja uses 8. And finally, we see that Nervi buries those ties that take out the horizontal force. He buries it underground so you don't see it, whereas Torroja has these ties above ground. So again, these are two different approaches. Neither one of them is bad. Actually, they're both great designs, but we see the different approach taken by the different designers for the same engineering challenge of a dome roof covering. This comparison of Nervi's little sports palace and Torroja's Algeciras Market Hall, you see again the different approaches taken by two different designers, where both designs are excellent designs, yet very different in the approach and in appearance. The works of both Torroja and Nervi were admired by another Spaniard named Félix Candela. Here in this newspaper clipping photo, Nervi and Candela are enjoying each other's company. Candela was born in Spain in 1910, and he researched reinforced concrete vaults, also referred to as shells or thin shell concrete structures. He researched them independently. It was not part of his formal education as an architect. He was exiled to Mexico after the Spanish Civil War, and it's in Mexico that we're going to see his many significant works being built. Candela can be defined as an engineer, builder, and a structural artist, which is the title of the book that David Billington and I co-authored in 2008. The geometric form that becomes synonymous with Candela's name is the hyperbolic paraboloid form, abbreviated HYPAR. It's essentially a saddle form where you see curvature happening in two directions. With the conoid that we've studied up to now, we have one line of generating straight lines to create double curvature. With a hyper, we have two straight line generators in two directions. Sometimes those lines are 90 degrees to one another, but they don't necessarily have to be. To demonstrate the many forms that are possible with a hypar, let's start with a single sheet, square sheet, straight edges, and it's warped, and the surfaces are generated with two straight lines that are 90 degrees to one another. The animation shows the warping of these two sheets. So you can see the straight lines generating curvature in two directions. If we take a cut, we have a hyperboloid circle that forms, and you can see that as the image rotates. Another cut creates a parabola. And this parabola is actually going to be the entrance to a church, an open-air chapel in Mexico, designed by Félix Candela. So by taking the single sheet and essentially slicing it in different ways, we arrive at the form for one of Candela's masterpieces, Chapalomas de Cuernavaca in Mexico. Chapalomas de Cuernavaca, seen here in this image, is a large open-air chapel, and it's still very much in use today. Another one of Candela's masterpieces is Restaurant Los Manantiales in Xochimilco, Mexico. It's hard to imagine that this very curvilinear shape for a restaurant was formed by straight line generators, but indeed it is, and in the next lecture I'll show you how. Candela built hundreds of reinforced concrete vaults, otherwise known as thin-shell concrete structures, out of this one geometric form, the hyperbolic paraboloid. I hope you'll join us next time to learn more about Candela and his creative designs.